Ah, Venice, a city literally built on water. And, well, for centuries, a city in a constant battle with it. And as the tides get higher and more frequent, the big question is, how do we protect this incredible world treasure? Now, you've probably heard about the massive multi-billion euro projects, but today, we're looking at an idea that comes from a totally different place. Okay, let's dive right in.
So what if the solution wasn't some huge feat of engineering, but something way simpler? What if the key to protecting Venice's delicate beauty could be found in materials you'd be more likely to see in a car factory than a massive construction site? It's a pretty wild question, right? And it is right at the heart of the proposal we're exploring today.
And there it is, plain and simple. The core idea is to use automotive-grade sheet metal to build a targeted, deployable flood barrier exactly where it's needed most. We're not talking about walling off the entire lagoon here, but protecting specific, vulnerable niches of the city. I mean, it's a complete 180 from the conventional way of thinking. Okay, so how on earth would this actually work? It sounds almost too simple, but there's a really clear blueprint behind it. So let's get into the nitty-gritty of how you turn giant rolls of metal into a protective wall against the sea. The whole system really just boils down to three main parts. First, you've got the barrier itself, these massive rolls of sheet metal. Second, the structure holding it all up, a series of posts that cleverly double as the city's lantern poles. And third, what makes it all go. Small, simple electric motors. That's it. No complex hydraulics, no giant concrete foundations. So just to give you a sense of the scale here, we're talking about a protective perimeter of about 5 kilometers in total. And to do that, you'd need 10 1-kilometer-long rolls of this sheet metal. When a flood threatens, they unroll to a height of about 2 meters. And these barriers would be held up by those lantern poles, spaced out every 50 to 100 meters. Now here's a small but absolutely crucial detail. How do you keep those poles from just getting knocked over by the water pressure? Well, they'd be designed with these cross-shaped wings at their base, anchoring them right into the seabed for stability. It's one of those simple, really effective engineering solutions. So let's walk through it. High water is detected, and those small motors kick into gear. Then, the sheet metal barrier just unrolls vertically, rising up into position. The source describes it as being like a string, and a small 30-centimeter section would always stay put at the base, creating a sort of permanent, low-profile foundation for the system. A simple design is one thing, but is it actually feasible? Let's switch gears and get into the practical side of things. We're going to focus on two of the most important factors for any project like this. How much does it cost, and how do you even install it? Given the massive scale of the problem in Venice, you'd expect any solution to have a mind-boggling price tag. So what would it actually cost to build this 5-kilometer sheet metal barrier? All right, check this out. The single most expensive part of the whole setup would be the 10 rolls of sheet metal, and the estimated cost for all of them together is about 150,000 euros. Now, looking at the chart, you can see that's the biggest single line item, but it's still just one piece of the total budget. And here is the truly jaw-dropping number. The total estimated cost for the entire project, we're talking materials, motors, installation, the whole shebang, is less than 1 million euros. Just let that sink in for a second, especially when you think about the billions spent on other larger-scale solutions. And the logistics? Just as straightforward. All the parts could be manufactured locally in nearby Italian cities like Padova or Ravenna, and the installation itself would be incredibly fast. The whole system could be deployed around the city using just one small ship. So we have a low-cost, easy-to-install flood barrier. End of story, right? Not even close. See, the vision behind this proposal doesn't stop there. And this is where it gets really interesting, because the system was designed with a second, totally unexpected purpose in mind. So picture this. It's summertime. The threat of high tides is low. Now, instead of retracting the barrier, the proposal suggests leaving it up for a long time. But why? To do something that sounds almost impossible, to intentionally dry out entire sections of the city. The idea is, with the barrier up, you could actually pump all the water out of a sunken part of the city. The area would, in the words of the source, look like a desert. And that creates this amazing, dry, accessible space, a good opportunity to renew, to call back to life the actual foundations of Venice. Let's just give this concept a name, renewal draining. It's an incredible thought, isn't it? using the flood barrier not just to keep water out, but to actively remove it. You could basically create dry docks inside the city itself, allowing for critical restoration work that's otherwise insanely difficult and expensive to do.
So when we put all these pieces together, what do we have? A cheap flood barrier that's also a tool for urban renewal. Let's try and wrap this all up and look at what makes this vision so unique.
So on the one hand, you've got the conventional systems. They're designed to protect the whole lagoon with massive, complex engineering that has one single purpose. But this proposal is fundamentally different. It's all about targeted protection for specific spots, using simple, cheap materials. And the real game changer? It's dual purpose, acting as both a shield and a restorer. So, what are the big things to take away from all this? First, it's a vision for a radical, low-cost alternative for flood defense. Second, it uses common industrial materials you can find almost anywhere. Third, it puts forward a totally new method for city restoration. And really, at its core, it's a whole philosophy of using simple, targeted interventions instead of massive, complex projects. And that really leaves us with one last big question to chew on. Whether it's for Venice or for any of the other huge challenges we face, it makes you wonder, in a world full of increasingly complex problems, what is the true power, the real value of a radically simple idea?